we have is network anomaly detection, CySA baseline versus suspicious activity. But yeah, we're going to go ahead and do network anomaly detection next. So then we go down to network anomaly detection, right? So how do they actually detect these network anomalies, right? So what are we going to learn, right? Establish comprehensive network baselines using multiple metrics. Identify various types of network anomalies and their potential causes. Apply various types of network anomalies and their potential causes. Apply statistical and behavioral analysis techniques for anomaly detection. Distinguish between benign anomalies and security threats. Implement automated anomaly detection systems. Respond appropriately to detected anomalies in enterprise environments. Fundamentals of network baselines. What is a network baseline? A network baseline represents the normal operating parameters of a network environment, established through continuous monitoring and statistical analysis of a network behavior over time. Components of a network baseline: traffic volume metrics, bandwidth utilization patterns, packet rates per interface, connection counts per time period, data transfer volumes. We are on protocol distribution, right? HTTP versus HTTPS traffic percentages. Not versus, I mean, you're going to be using both of them, right? One is for more security, right? The other is just plain text used for stuff that doesn't require a lot of security, right? DNS query volumes, email protocol usage, application-specific protocols, right? For communication patterns, we have internal versus external, traffic ratios, peer-to-peer communications, client-server interactions, geographic traffic distribution. We have temporal patterns, business hours versus off-hours activity, daily, weekly, and seasonal variations, peak usage period, and maintenance windows, right? Times where you're going to be offline for maintenance, right? Importance of baselining. Anomaly detection foundation establishes normal behavior, provides comparison metrics, reduces false positive, improves detection accuracy. Benefits of security baselining: early threat detection, insider threat identification, data exfiltration detection, command and control identification, right? You do have some operational benefits: performance monitoring, capacity planning, troubleshooting assistance, change impact assessment. Module 2, you have baseline establishment methodology, data collection strategy, collection duration, minimum 30 days for initial baseline, 90 days for comprehensive baseline, continuous collection for refinement, seasonal adjustment periods, right? For how you collect data. What is the baseline for your data collection, right? Network traffic metrics is all like the data relating to network traffic, right? Or the percentage, the rates, the people that were active the most, top talkers and listeners, right? Geographic traffic flows, even the packets per second, right? Performance metrics, we have latency measurements, packet loss rates, jitter statistics, throughput measurements, queue depth, error rates, failed authentication attempts, firewall deny logs, IDS IPS, alert volumes, DNS query patterns, certificate usage patterns, encryption protocol usage, right? For statistical analysis methods, we have central tendency measures, mean, median, and mode. That's like math. You should have learned that in math, right? The average and the middle and the mode. Algebra 2, you definitely have to know that, right? For like ratios and stuff like that it would pertain to, right? Variability measures, right? Standard deviation, variance calculations, range analysis, percentile distributions. For the statistical analysis, statistics are like numbers, right? I'll think of numbers. Time series analysis, trend identification, seasonal decomposition, moving average regression analysis. Tools for baseline creation: network monitoring systems, PRTG, network monitor, SolarWinds NPM, Nagios, Splunk, right? Nagios works with Splunk, right? Or Splunk made it, right? Zabbix is also another tool, but I'm pretty sure Nagios is like built into Splunk. I don't really know how to pronounce that. Flow analysis tools: SolarWinds NTA, Pixel Scrutinizer, Manage Engine, NetFlow Analyzer. NetFlow shows you like graphs or data that you can analyze of your network, right? To show what's flowing in and out of your network. PRTG NetFlow. PRTG one is another NetFlow one, right? SIEM platforms, we have Splunk Enterprise Security, IBM QRadar, ArcSight, ESM, Logarithm. And those are only a few, but those are more enterprise environments, right? You're not going to be putting IBM QRadar in a personal environment, right? Unless you want to. I mean, no one's stopping you, right? But I mean, I'd recommend looking at WASA. WASA's a really good one, right? But it's more of like for threat detection and endpoint detection and response stuff than a actual SIEM, right? But I mean, it still acts as a SIEM as well as those threat detection, and it doesn't really detect threats. It just helps you like sort of detect them, right? If you have it set up correctly, I'm sure it could detect threats. But for types of network anomalies, we have volume-based anomalies, bandwidth anomalies, sudden traffic spikes, unusual sustained high usage, off-hours traffic increases, geographic traffic shifts, connection anomalies, excessive connection attempts, unusual connection durations, connection pattern changes, and port scanning signatures, right? Those could be network anomalies, right? Protocol-based anomalies, we have protocol distribution changes. Normal HTTP is like 40%, HTTPS is 35%, DNS is 10%, SMTP 8%, and 7% for other protocols. Anomalous would be HTTP not using very much, HTTPS not using very much, only using 25%. DNS it's using like 45%, meaning I'd think of that as like a DNS attack rate, because who's using that much DNS servers, right? Then we have simple mail transfer protocol is using 3% less, and others 5% less. So it's using a lot less traffic than our normal traffic rate, but it's using so much more DNS that it just doesn't make sense, right? So I'd rule that out as like someone is attacking you with DNS servers, right? Whether it be ARP spoofing, stuff like that, or a DNS hijacking, stuff like that. For protocol behavior anomalies, unusual DNS query patterns, abnormal HTTP request sizes, unexpected encryption usage, non-standard port usage. Temporal anomalies, time-based deviations activity, outside business hours weekend traffic spikes, holiday period activity, maintenance window violations. Regular beaconing patterns, unusual periodic communications, missing expected traffic timing pattern changes, behavioral anomalies, user behavior changes, unusual access patterns, privilege escalation attempts, and data access anomalies, geographic location changes. Then we have system behavior changes. This is when like registry keys are changed, just anything out of the ordinary that someone changed on your system. But when I think system behavior changes, I'm like, why aren't you using secure boot? Secure boot could have helped you a lot so that it would actually verify every time you booted. If your system changed, it wouldn't let you boot, right? Or it would let you boot and just be like, something changed in your system, but I've never really tested that before. That would be a cool lab though. Say I changed something in the kernel, see if secure boot still lets me boot up. That'd be a cool lab, right? Of course it wouldn't let you boot up, right? Or it let you boot up, but I don't know if it would tell you or what it would do. Statistical detection methods, threshold-based detection. So this is threshold, right? If it goes over a certain threshold, you understand, right? Z-score is your mean value. All your values added up and divided by the number of values would be your mean values, right? So you have two Z-scores. So you would do 2 plus 3 divided by 2. That's 2.5 is your standard deviation. And I just know that mean value means average value. So to get the average of these, you would add 2 plus 3. You divide by 2, right? Because you're doing those two Z-score values. So you divide it by the number of values that you added together. And that will be 2.5 as their standard deviation for the Z-score. For machine learning approaches, you have supervised learning, known attack pattern recognition, classification algorithms, training with labeled data, high accuracy for known threats, unsupervised learning, clustering analysis, outlier detection, pattern discovery, unknown threat identification. So they're saying basically one of the machine learnings is supervised. The other one can do whatever it wants, right? It doesn't have someone checking over it, making sure that it's doing what it's supposed to, right? Semi-supervised is halfway supervised, and the other half it's just letting it do whatever it wants, but still showing you what it's doing, but still doing it anyways, right? Signature-based detection, known attack patterns, port scan signatures, DOS attack. You know what a DOS is, right? Denial of service attack. It's when you're denied service because either someone attacked you or something got unplugged, or it could be for various number of reasons that extends way far beyond the CySA plus, right? Well, not really, but for malware like communications, because a DOS attack's just like ARP spoofing, ICMP flooding, stuff like that. Data exfiltration signatures, right? Pattern matching. Rule SYN flood detection if TCP SYN packets equals 1,000 minutes and TCP SYNAC ratio is 0.1, then it'll alert that there's a potential SYN flood, right? Behavior analysis, we have communication pattern analysis, source destination relationships, communication timing, data flow directions, protocol usage patterns, user entity behavior analytics. So it just figures out what a user's doing and fingerprints them so it can get more data off of them, right? I'm not sure if it does fingerprint with Yuba, but that'll be something that they could add to Yuba. Like a website automatically gets fingerprinting data, right? Benign anomaly characteristics, legitimate business changes, software update patches, new application deployments, business processes changes, schedule maintenance activities. Environmental factors is like network infrastructure changes, ISP routing modifications, your internet service provider changed how they routed stuff, external service outages, seasonal business variations. So certain times of the year, businesses will do different stuff. So that's what they're talking about, seasonal business variations, to detect for that. Malicious anomaly indicators, attack signatures, multiple failed authentication attempts, unusual outbound connections, large data transferred to external host, communications to known bad IPs. So they look for those signatures of all those bad IPs that could either be bad because of malware or phishing, stuff like that. Suspicious timing, off hours, administrative activity, rapid successive actions, activities during known vulnerabilities, coordinated multi-square activities. We have temporal context, spatial context, and historical context. So that's time-based. Spatial is like where in time and space is this thing happening on the network. Historical context, previous similar events, pattern evolution, incident history, threat intelligence correlation. For common attack patterns and signatures, we have network scanning that might detect the SYN flooding, right? Or DNS enumeration. So it's scanning for those bad IPs, right? Or bad domain names through DNS queries and checking for those query patterns through a dictionary-based subdomain query through the NX domain record. NX domain's a record, right? For data exfiltration patterns, we have large file transfers, which could signal a data exfiltration alert, because no one should be doing like 5 times the normal data, taking data off, right? They shouldn't be doing that, especially on off hours where the business isn't even operating or it's closed, right? DNS tunneling pattern abnormally, large DNS query responses, baseline deviation DNS packet, size 512 bytes, frequency regular periodic DNS activity. Content is base 64 encoded data, and these queries, which could indicate that they're trying to download malware or something on your system, right? Through this DNS tunnel. Well, they still have to have something to run it, but if they already had a command and control server or a backdoor into your system, they could just download it, then run it through their command and control server, right? Beaconing behavior for a C2 server, pattern regular periodic outbound connections. So most times you want to block inbound connections, right? But you never thought about if someone gets on your system, they can do outbound and send stuff to their C2 server. So checking for periodic outbound connections is really important. Baseline deviation, new periodic communication pattern. Timing consistent intervals every 300 seconds, right? Destination single external IP or domain. So that's saying check for outbound connections. That could be the C2 server beaconing to the attack server, right? The C2 server basically. Domain generation algorithm, DGA, is pattern DNS queries to algorithmically, I don't even know how to say that. Algorithmically generated domains. Baseline deviation, high index domain response rate. Query pattern seemingly random domain names. Timing burst queries to multiple domains. That could signal that you're using a domain generation algorithm. If all these key factors that I just said are happening, right? Denial of service is like volumetric attacks. Pattern is massive traffic volume. Increase baseline deviation 100 times. Normal traffic volume. Source pattern, multiple external sources. Target pattern, single internal destination. Protocol attacks, pattern malformed or excessive protocol request. Baseline deviation protocol, specific anomalies. Example, CYN floods, UDP floods, and HTTP floods. Resource impact connection, table exhaustion. So that could be examples of these protocol attacks. The malformed packets, the excessive protocol request, is an example of a protocol attack, an indicator of a protocol attack. For automated anomaly detection systems, we have security, information event management, integration, event correlation, multi-source data aggregation, pattern recognition across events, contextual analysis capabilities, automated alert generation, role configuration examples. Some of the examples, right? For whatever scripting language this is, right? Machine learning, unsupervised learning models, isolation forest algorithms, one-class SVM, autoencoders for anomaly detection, clustering-based outlier detection, real-time processing, streaming analytic platforms, low latency detection systems, scalable processing architecture, and edge computing integration. For NBA tools, network behavior analysis tools, we have commercial solutions, Darktrace, ExtraHop, Vectra AI, Corelight. For open source options, we have Suricata, Brozeek, Selks, and Security Onion. For Module 8, we have response and investigation procedures. So this might be some of the things that you would do when you're responding and investigating an incident. Initial assessment, severity classification, impact scope determination, resource requirement evaluation, escalation criteria assessment, data collection, relevant log aggregation, network traffic capture, system state documentation, timeline reconstruction, analysis and validation, correlation with threat intelligence, historical pattern comparison, false positive elimination, and root cause analysis. Investigation, methodology, temporal analysis, event timeline creation, sequence of events mapping, duration and frequency of analysis, pattern evolution tracking. Network forensics, we have traffic flow analysis, protocol level examination, communication pattern mapping, data reconstruction attempts, threat hunting activities, hypothesis driven investigation, indicator of compromise validation, lateral movement tracking, persistent mechanism identification. For documentation, you have incident documentation, anomaly descriptions and classifications, detection methodology used, analysis findings and conclusions, response actions taken. Baseline updates, we have legitimate anomaly incorporation, thresholds adjustments, rule modification, model retraining requirements. Module 9, we have performance optimization, threshold adjustment for tuning strategies, threshold adjustment. We went over a lot about tuning strategies already. Machine learning, we have feature selection improvement, model parameter tuning, training data quality enhancement, and ensemble method implementation. Scalability, right? Scaling up your network anomaly detection, data volume management, and real-time processing. For key exam concepts, we have baseline establishment, understanding normal network behavior, statistical analysis methods, temporal pattern recognition, protocol distribution analysis, anomaly classification, volume-based anomalies, protocol-based deviations, behavioral changes, temporal irregularities. For attack pattern recognition, we have reconnaissance activities, data exfiltration techniques, command and control servers, communication servers, denial of service attack patterns, common exam scenarios, identifying port scans, recognizing scan signatures in network data, distinguishing scan types and methodologies, understanding scan timing patterns, detecting data exfiltration, unusual outbound traffic patterns, off-hour data transfer activities, covert channel communications, recognizing command and control communications, beaconing behavior identification for that outbound traffic, DGA domain detection for generating domain names, right? So you have DGA domain detection for C2 communications, command and control servers. Why are DGA domains a problem? Let's just figure out, why would a DGA domain be a problem? So Akamai, they say, to go a little bit more in depth on why DGA domain generation algorithms are bad, it's because cyber criminals use them, right? And I'm just on this website that talks more over it, right? But you see sort of how it works. The attacker sends a malicious executable that starts up a C2 server that relays back to the attacker's PC. That C2 server is generating domains, sending them to a DNS server, and sending back an NX domain, right? Which I could see that as a DNS attack, right? But what is it actually doing? How is it affecting organizations, right? Adopt an optimal. So it's basically malware that could be a botnet, could just be malware that encrypts your files. That's called ransomware. Malware that encrypts your files is called ransomware. But what are domain generation algorithms? I'm reading it here. It says applications that use a sequence of characters. I'll scale this up. Applications that use a sequences of characters to quickly produce thousands of domain names that could serve as a rendezvous point where attackers can communicate with C2 servers. These algorithms can generate tens of thousands of domain generation algorithm domain names a day, most of them unregistered. Hackers use these unregistered domains to hide the registered ones, making it easier to evade detection by inspection engines that use signatures and IP reputation. The algorithm is executed on both the client and source sides. It starts with a seed that is known to both the attacker and the C2 server, allowing both to know which domains will be generated and which domain will be registered to serve as the communication channel for malware. If that domain is identified by security systems and blocked, attackers can quickly switch to another domain name to maintain contact with the C2 server. So basically, what I'm getting from this is basically they make all these like unregistered domain names that don't really mean anything, so that even if you got rid of one of the domain names that the attacker put on your computer with malware, right? They can go get another domain and be like, oh yeah, we're still connected to you because we have a bunch of unregistered domain names, right? That can relay us back to your computer, your PC, right? So that's basically what it's showing here, but it's showing with DNS server. So the DNS server will be like generating all these DGA keys, unregistered domain names, right? So that the attacker can operate. Even if you get rid of one of the domain names, the attacker can still access your computer. So that's what DGA actually is, and why it's so important to know for command and control communications that attackers use. Also, attackers can use encryption as well. So, most of the time, attackers use an encrypted tunnel to send back that data where it gets unencrypted whenever the attacker gets it, right? Performance versus security events, differentiating between network issues and attacks, understanding legitimate traffic spikes, recognizing infrastructure problems. For exam tips, we have understand statistical concepts, mean, standard deviation, percentiles. So you need to know mean, median, and mode, how those tie into that number scheming, statistical analysis. Just if you know that type of math, right? Memorize common attack signature patterns, attack signatures and patterns. Practice baseline calculation methods, calculating what your baseline is and how far that deviation is off so that you can calculate and make these alerts. But this is mainly for network anomalies like traffic spikes, stuff like that. But you need to know the difference between correlation and causation. How was that correlated, right? Versus what caused it. Study real-world network behavior examples. So how the other people set up their networks, like enterprises and stuff like that. So we do have some labs that we could do. Objective, create network baseline from sample data. Yeah, it's just analyze 30 days of network traffic. That was a lab for Wireshark as well. But you probably would be using Wireshark to analyze this network traffic data and flow analysis patterns with NetFlow. And you would document it. You would identify normal patterns, calculate statistical measures. For anomaly detection, you would configure anomaly detection rules, set up threshold-based detection, implement statistical analysis, create alerting mechanisms, test detection accuracy. So it's just not one thing. Configuring them, you just don't configure one thing. There's multiple different things that you would have to test and implement before you'd actually have everything up and configured. Attack pattern analysis, identify various attack signatures, analyze port scan traffic, detect data exfiltration attempts, identify command and control communications, classify attack methodologies. So attack signatures might be malware signatures, stuff like that. But for this, they're saying it's actually network attack signatures. It's not really anything. But most network attacks that adversaries use is malware based because they're trying to get malware in your system. But they're doing that through the network, like we showed with the DGA method. For false positive management, we have optimize detection accuracy, analyze, and I mean, this isn't just one lab. This could be a whole lab. Lab 4, I mean, all these labs, you can have one big lab that just goes over how to do all this stuff, right? But I just broke it down into these labs right here. Analyze false positive alerts, adjust detection thresholds, implement whitelist rules, validate improvements, incident response integration, integrate anomaly detection with response procedures. So this will be sort of like the automation part of it, where you detect the anomaly, then you do something. But you have guardrails in place. But for this, they say create responsive workflows. How do you work through and how do you automate these actions and stuff like that? You document investigation procedures and you test the response effectiveness. How the testing is, how able was it to stop this network anomaly from happening, right? So think of it like you're testing to see if that thing was able to be stopped. Like with an IPS, you'd be testing if certain attacks were able to go through. IPS is intrusion prevention system, but it's really important to know how to do for the test, right? For tools and technologies, we have commercial network monitoring tools, SolarWinds NPM, PRTG network monitor. Open source, we have Nagios and Zabbix for network monitoring tools. Flow analysis, we have NetFlows, flow analyzers. For traffic pattern analysis, seeing how stuff is flowing through your network and seeing who is using the most traffic, right? And you're able to see how different users or IP addresses, what they're doing on your network, right? Who's using up the most resources. That's what they mean when they say top talker identification. Application usage monitoring, security event correlation. That's why you would want those flow analysis tools. Then for other flow analysis tools, we have Enterprise Solutions, Splunk, Enterprise Security, IBM, QRadar SIEM, ArcSight ESM, Logarithm SIEM. Open source, we have OSSIM, Alien Vault, OSSEC, ElkStack with Elasticsearch, and Logstash and Kibana. Then we have WASA, and those are all open source, and you're able to use and test them however you would like in lab environments or production environments. Best practices and guidelines: baseline management, regular updates, quarterly baseline reviews, seasonal adjustments, considerations, business change impact assessment, technology upgrade accommodations, documentation standards, baseline parameter documentation, change management procedures, version control implementation, stakeholder communication protocols. We have detection optimization, continuous improvement, detection accuracy measurement, false positive rate monitoring, response time optimization, coverage gap identification, continuously improving with a DevOps workflow. But what is DevOps, right? DevOps, if I look up what is DevOps, it is a sort of like a business model of how stuff is integrated with security in mind and how the developers are integrating that security and communication with teams and stuff and IT operation teams. So it's basically a business model where you could see continuous improvement, detection accuracy would all tie into DevOps. You would have to know that if you're going into a DevOps role like DevOps engineer. For team training, we have regular analysis training, tool proficiency development, threat landscape awareness, response procedure practice, integration considerations, enterprise architecture, security of information event management platform integration, threat intelligence feeds, incident response workflows, compliance reporting requirements. For the enterprise architecture integration, for case studies and real-world examples, we have APT detection through baseline deviation, long-term compromise detection, baseline deviation, gradual increase in DNS queries to external domains. They investigate process timeline analysis and indicators of compromise correlation to figure out about what time were we attacked and what indicators of compromise were they correlated to. So with a rough estimate, you wouldn't want a rough estimate, you want pretty much good timing so you know when the attack happened. Outcome, advanced persistent threat identification and remediation. What was the outcome of this advanced persistent threat? Case 2 study. Insider threat detection scenario. Employee data theft investigation. Baseline deviation off hours. Large file transfers to personal cloud storage. Investigation process, user behavior analysis, and data classification. Outcome, insider threat identification and policy enforcement. DDoS attack early detection. Scenario, distributed denial of service attack prevention. Baseline deviation, unusual inbound connection pattern from multiple sources. Investigation process, traffic pattern analysis, and source correlation. Outcome, attack mitigation before services impact. Network anomaly detection is a fundamental cybersecurity skill that requires understanding of both normal network behavior and potential security threats. Successful anomaly detection depends on comprehensive baseline establishment, understanding normal network patterns through statistical analysis and continuous monitoring, accurate anomaly classification, distinguishing between benign operational changes and potential security threats, effective tool utilization, leveraging automated detection systems while maintaining human expertise for analysis and validation, continuous improvement, regular baseline updates, detection rule refinement, and analysis training, integration with response procedures, seamless connection between detection capabilities and incident response activities. The ability to establish baselines, detect anomalies, and respond appropriately is essential for cybersecurity analysts and critical for success in CySA Plus certification examination and professional and real-world experience. But the main thing is to actually learn something from taking the certification, right? There's some reference materials, online docs, professional development, and network anomaly detection represents one of the most critical skills in modern cybersecurity, serving as the first line of defense against sophisticated threats that traditional signature-based detection systems might miss. So that is going to be Anomaly, network anomaly detection. Thank you for watching.